Last night, over a couple of cocktails, I managed to convince Felix Laboy from Vibranalysis to not spend the entire day on the beach, to actually do some work.
Since 6:30 in the morning.
Yeah, exactly. So anyway, it's great that you could step in. Thank you very much, Felix.
Did I have a choice?
No. Felix has known us for a very long time. He's one of the premier service providers that you're going to ever run into. So it's a great pleasure to have him here. He's a great presenter and a great friend. Thanks.
Thank you. Okay, this is working. Perfect. Okay, disclaimer. If you do not understand me, it's not a technical problem. It's not a translation problem. English is not my native language. Okay? So I'm going to try. I'll do my best, basically. And in this case, with this short notice, I came up with an idea that we have been working. My background, 30 years working with the industry, different vertical markets. We have been concentrated. We started as a CVM program provider, and we have evolved. And I want to show you how we have gone through the time. And first of all, we will be talking for the first time of a friction index. Something different. So we'll see it. Talk about maintenance. We have different strategies. How do we work with our assets? First of all, we have reactive maintenance, preventive maintenance. We have different styles. I want each of you, according to my presentation, define where is your plan. First of all, the firefighters, which is the reactive maintenance. Surprisingly, I still see a lot of plants that they have failures. Okay? Production capacity is not unknown. That's one of the problems that we have. We have these failures. And what's a failure? This sounds like a failure. You have seen it. When the customer calls us and say, can we repair this? Yes, we can try. But the second statement was really difficult. In 24 hours. No way. You have heard that before? Production. This fan holds 25% of this plant. It's a tablet plant. Customer, I cannot say the names. That was funny. We told them, no, 24 hours, we can only replace it. So you be in that spot. Let's see the other one. Do you see something wrong with that bearing? No. No, that's what the customer, he told me, what's wrong with that bearing? It's just that it's supposed to be hold down here. And you can see they call us around midnight because they want to repair. Brave people. So we told them, no, it's not that easy to work with it. So eventually we evolved to a different type of maintenance, which is, I hope most of you are working today. The famous preventive maintenance. Every plant should have a preventive maintenance. That's what we thought about in the 1970s. Computers came up, software came up, Maximos, apps. And today, everybody should have a preventive maintenance. What happened with this one is, typical, is based on time. How much the clock moves. You have a computer that sends you a message. You have to do a repair. In this case, the computer was sending a message to this mechanic to go and grease this motor. I think that you have seen this one. That's not graffiti. In this case, everything is supposed to be red. Something is wrong there. The mechanic was doing his job perfectly. He was going every month and he was greasing. Checking out PM, done. Further down, he was causing another problem. So in the 80s, we saw these problems and we say, we cannot continue with this. We need to improve. What's next? Human, we are always looking what's next. So we came up with an idea. Voila. Predictive maintenance. Did you believe that? That I can predict the future? Honestly. That was what I saw back in the Caribbean. You were safe. I was out there selling that I can predict the future. Everybody bought it at that time. It was a sticky, predictive. Oh, he can predict the future. Wrong. But they bought it, and it was nice. But it was a whole different concept. Instead of me doing a PM, which is let's do an inspection, we changed that into let's do an analysis. So we started doing anticipating. That's what we do. If I can be able to predict the future, I won't be here. Yeah. You will be seeing me through a camera here. Basically, what we do with all of these technologies, vibration, thermographic, oil, ultrasonic, motor current analysis, we are only doing is anticipating problems by monitoring with non-destructive technologies. Okay? CVM, condition-based maintenance technologies, allows the condition of component to be measured. That's what we do. We apply some technologies to know the condition of our assets. Maintenance needs are anticipate and plan it. If we do the planning, how many of you have a planner at your plant? Everybody should have it. But a real planner, not a purchasing guy, not a scheduler, a planner. And maintenance has minimal impact in production. All of us should be looking at production. That's our customer. And that's where we came with. We came a whole line of different products, different technologies, and we call them predictive maintenance. We apply all of them. Some of them we work with the rotating equipment, electrical equipment, but we call it assets. We don't talk about equipment. Today we talk about asset because it can be mechanical, electrical, stationary, all of them. And we have to decide which of these technologies we're going to apply to one asset. Because we are talking today, this is a key word. I visit a lot of plants, and they say, yes, we have a predictive maintenance program. Okay, what's that? We do vibration, we do ultrasound, we do infrared. But today, if something I want you to take back home is, we're talking today about integrated. Meaning that we use different technologies to assess one asset. And besides that, how do we report that asset to our organization? Because most of the technical guys, we like to do analysis. Do we like to write reports? Wrong. We need to talk to the management. Management doesn't talk about vibration, dBs, temperature. They talk about what? Money. and you need to start working with the money. You don't have to be a financial person, but you need to write reports. And there is a lot of ways you can talk about cost savings, return on investment. I don't believe too much on cost avoidance, but that's another way you can put it. But we need to talk their languages. And one of the things that I have seen within the technical people is, if you don't know how to do that part, at least present to the management red, yellow, and green. Everybody knows about that. Traffic light. If you show to a manager that his asset is red, he knows that means stop. There is a problem. And if it's green, I like to call it, it's the color of the dollar, we're doing business. Okay? So that's what you have to do. If you're doing analysis, ultrasound, any of those technologies, but if you're not doing this presentation for your team, for your plan, we're doing something wrong. And let me warn you, you're not going to last because you're not selling. I have been so many times to the front of management of a plan, and they say, what you have returned to us. You're really expensive. We are. Where is the money that I have invested? I was so tired about that question, because looking for cost saving, looking for cost avoidance, and we say we have to represent to the customer. What's the return on investment? That's it. Oops, we went back. Now the customer can go to a website, not report, no paper. Papers, where did they go? To a draw. In this case, it's a platform that they will see. And who should be seeing this? Maintenance people only? It needs to be on a website because operations needs to see it, quality control needs to see it, everybody has to see it. And the only way to show that to them is through a website. So you have to go and start thinking about what's more important, doing the analysis or doing the marketing. Proactive maintenance. After doing all of this CVM, I would say, well, okay, what's next? Now I have a CVM. What's the next step? Proactive maintenance is what we have been working for the last 5-8 years. Is extending machine operation, which is different. That's what I placed this question here. What is more important, machine life or machine operation? We are measured today on how long that machine is working, operation. And that should be the goal of all of us. Not life, let's talk about operation. Extending machine operation by applying advanced investigate and corrective technologies. How many of you are doing RCA? Root cause analysis. RCM, TBM, there's a blend of all. All of them are good, but you have to take one or make a combination of them, because you need to start looking for why. And further down, I'll show you a PF curve. We need to start thinking about why fail. What's the expected life of a ball bearing by design?
20 years.
Huh?
20 years.
20 years? Okay. Does the bearings on your plant last that? Maybe 20 days. I have customers that happens. And the problem is, they just leave. It's incredible. They say that's normal. No, it's not normal. That's where we started with all of these predictive, proactive analysis. Let's see what's the problems there. Now, I have shown you 3 strategic. I want you to answer my question. Where is your plant? Which of those three? Which of those four? And most of you will say, well, I'm between preventive, predictive, or maybe predictive, proactive, somewhere there. Let me show you what I have seen in Latin America. I do a lot of traveling through Latin America, benchmarking, and I have seen that these are the best benchmarking, because we need to be always doing benchmarking. Somebody else already invented the wheel. Why we are always looking to build a wheel? In this case, through Latin America, as you can see that most of my plants, they are reactive, round to failure. Most of them. And they're moving fast. They already saw that here is most expensive way. Okay? Let's see how is USA. Is that familiar with you? Are we doing a lot of PMs? Most of the plants that I visit, that I work with them, they know that we have a lot of PMs. And you know the next question, if you're doing that much of a work on PM, why still you have failures? There's something wrong. But there is a solution for that, okay? But in this case, that's what we've seen. So that's a standard in the industry. If you have seen this graph, if you haven't seen it, get a copy of it. Because that's the way, how do we move from round to failure, preventive, predictive, and where we want to be. And it's the easiest way to talk about why we want to move from one strategic to the other one. Management love it. And it's easy for me to be in front of a management team, no engineers, financial people, management, lawyers, and explain to them the PF curve. It's important to you go through it. And it's so simple. And most of us right now, we are working here trying to move to this place. Do you know that most of the failures that you have at your plant are not maintenance driven? Who is here in operation? Why we have always maintenance people and there is no operation? Most of the failures that you have at your plant is operation. And you know why? Because when you go and dig into them and see, they don't know how to work their units, how to operate their plant. They have been doing what they were taught. That's all. They're not bad people. Nobody wakes up in the morning and says, I'm going to wipe up a bearing today. It's going to be me. No. It's just that we have been concentrated here, but we need to start working on the root cause of our problems. Major offenders. And that's how we work here. I'm not going to talk about this place because it's obviously. Do we know what's consequential damages? If we have a deviation, I like to talk about deviation. The ball bearing has a fault, has a problem. If we let that ball bearing continue working, what's going to happen? It's going to damage what? Shaft, housing. Those are consequential damages. It's so, in this case, we can save so much money here than down here. In our case, we are looking for working on predictive. During the 2000s, it was said that the company that by 2010 do not have a CVM, condition-based maintenance program, will not last. Believe it. It's the truth. Today, if you don't have a condition-based maintenance program at your plant, you're not going to last. Because I'm working with your competition down South America, down the Caribbean, and they're doing it. Everybody has to have this. Okay? But once you're here, you will start saying, what's next? The what's next is, how do we do this? Proactive. That's where we are today. Looking for the cause, the root cause of the problems. After being the leader, in this case, for 16 years, it's always asking, what's next? Today we have a lot of our plants where we have our CDM program. Then we started with the reliability area. If you're here, it means that you have heard that word. Okay, what's reliability then? Reliability, I've been working with that, and everybody wants reliability. I want to know, I want to do it. As my friend Paul told us this morning, it's not an easy. Volume now? Got it? Thank you. So in this case, what is that? After being working with a lot of companies, working with one field, we have seen that reliability is a combination of 5 areas. Believe me, I have worked for the last 8 years trying to improve plants, and if we don't work on all 5 areas, it doesn't work. We don't get the results that we want. Because I have done it so many times. I have started with this area. That's my background, maintenance. Let's work with the maintenance part. Let's work with the CVM program. Let's get that CMMS program sharp, working. But what happened? If I don't have planning and scheduling, what happened with all of those diagnostics that you did? We do a lot of, you have this problem, check this, lubricate, repair. But if it's not done, you know what's going to happen? Most of our customers, they say, well, if you're doing those analysis monthly, let's do it now bi-monthly. Because we cannot repair. Oh, hold it. Does that have sense? Because I have others that say, 2 months is not enough. I need 3 months. So that's where we start doing deviations of the program, so we don't have planning. But what happens? The other one is that I need to do a repair. I know that I have to replace that electrical motor, but when I go to the warehouse, the electrical motor is not there. Voila, we go back to square one. So now you see that if I'm doing this, but I'm not working with this or working with this, nonsense. Believe me, I have suffered. But the worst part comes, still not ends. Let's go to the next level. People skills. Do you mechanic know how to do lubrication? Yes. You put grease until
it comes out.
It comes out through the seal. Yes, that's the way you grease. You know that it's enough grease, but you're blowing out the seal. And we have found out that our people, maintenance people, they are not qualified to do a lubrication. Something that's one of my quests today. Because we say lubrication, forget about that. Who do that? Who's the one that lubricates? Well, the one that passed by my office, do you have something to do? No? Okay, I have a job for you. And believe me, For me, lubrication is more important than doing analysis. Because you are the ones that are making most damage to your equipment, to your assets, through the lubrication. Is somebody here from Noria? I'm selling that. I need some commission from them too. So we have seen that if I don't have the skills within my people, not going to work. How many times we have say, let's replace that ball bearing. They go and replace it. We do a certification. And what happens? We still have the same problem. Because they did a wrong installation. They got the wrong bearing. They did a wrong lubrication. Because they were not qualified. And our biggest enemy, no, they're not enemy. They just have been not invited. Operations. We need to work with them. We need to work with them on TPM. We need to work with them on coordination. The biggest problem that I have with operation most of the time, the first time is that I go there and say, I need this asset to do a repair. What is the answer?
No.
You have gone through it. Okay? And now when I ask why no, because I need to work with the production schedule, which at the end of the day, everybody should be working that. But it's not that easy. We need to start talking to them. That's why when we have a course, we invite maintenance and operations so they can start looking at, when we say we are doing an ultrasound, those are the results, now they believe on us. Because if we don't teach them how to do it, how we do this magic, they're not going to help us. So those are my areas that, based on my experience, and I have talked with a couple of the seniors, you have to work on those 5 areas in order to get a reliability improvement. Now that we have reliability, we have CVM, everything was nice, we got the crash, 2009. But this was suffered, I would say, since 2006. How many of you that have budget, they told you, now we need you to do more with less? You have heard that before? The first time I heard that, I said, do I'm a magician? Something like that. Do more with less. Now that I have my CVM program working, now that I have my reliability working, they told me you have to let go 2 people. Who's going to be doing the analysis? Who's going to be doing the data collection? What we do. So we started working on this. And we have an idea that I want you to work on it, because this is basically, they told me, from all of these technologies that I'm applying to an asset, how do I shrink that? I have to do all of them, supposedly. And they came to us and said, well, you're the expert, you're the CVM service provider here. What's next? So we started working, and we say, how do we work here? If we have a plan, and be careful with this, if you have a plan under control, which most of your assets are green, do you have to be doing all of the technologies? Yes, maybe. Why we don't start working with let me use one technology to be a flag for the other technology? And I have to say that in this case, I'm not the owner of the friction index. I'm not the inventor. I'm just a person that be challenging, and it's Carlos Garza. He's the one that we have been fighting. My background is vibration. Who started here? How you started? Vibration. How many of us started with vibration? The first technology that we learned. How many of us started with infrared? That was the first technology. How many of you started with oil analysis? Voila. I started with vibration. Then I moved into infrared. Then I moved into oil. And the last technology that I learned was ultrasound. I don't know if that was good or bad. That was the day that I met Hugo. We'll see that. We've been doing together 8 years. But in this case, last year we started with this idea. Why we don't use ultrasound to be a trigger for my vibration analysis? I told Carlos, you have to be crazy. I didn't saw it at that moment. But the whole idea, and I want you to start because we already have a couple of plants. We have BP, we have Medtronic, we have different vertical market. We have a BP, which is refinery. We have another one within the pharmaceuticals, different markets. What we did was, in this case, we say, if we have the plant under control, it's green, it's under control. That's a key, that's really important. Because you have seen, you can't see it here, but one of my statements here is lean on reliability. And it has a sense. I had a lot of customers that had say, Felix, we went too lean. Because when you want to optimize, lean means optimizing. When you try to optimize something that is not stable, what's going to happen? It's going to be a big problem, my friends. Because as Paul told you, the first thought of lean, which I like it, but first, to optimize something, it has to be stable, reliable. Because lean will say, okay, let's bring down the warehouse. The amount of assets we have there, spare parts. Those spare parts are there because there is a reason. So that's for me really important. This concept that I'm showing you will apply to a reliable, stable plant. Where the whole idea here will be, I will stop doing further analysis until I have a trigger that tells me that there is a deviation. And let's take it as simple as rotating equipment. Let's talk about pump. How many of you have pumps? Everybody. If I'm having a problem with the ball bearing, lack of lubrication, would that be the first step of any failure in that pump with that bearing? When you do the root cause analysis of a failure on a pump, on a bearing pump, what's the first root cause? Bearing failure. Lubrication failure. So if I have something monitoring lubrication, when the lubrication fails, I will notice, I will know. Will that work? So what we're doing today is we are doing ultrasound, which we call it friction index. When the friction goes up, what happens? The bearing will start getting overload, and eventually it will have some vibrations. So when we are talking about what do I use as a flag to show me that we have a problem that is developing a problem, that's what we're doing. We're using ultrasound. And the whole idea here is we have gone measuring the DVs, ultrasound measurement, friction index. When that friction index goes higher to a value that we know that is not acceptable, we will do an analysis there, vibration. Now, from measuring vibration every month, the first step, we're doing it every 2 months. I'm saving man hours there. And my next step is 3 months. That's an additional man hour savings. It has sense. Because in that case, that's a tool that I have right now to lower my manpower. Instead of using all of these technologies. And I'm presenting here the mechanical side. Infrared, that's another application. So, in our case, we are working to reduce the amount of manpower, data collection, using ultrasound. And we have been successfully working with this in a couple of vertical market, different plants. You'll see it next year. Any question? Don't talk, everybody. Yes, sir? Will you please give Alan a time so he doesn't have to run?
I was just wondering if you could speak a little bit about the friction index that you showed.
The friction index, basically, what we have done here, we did a benchmark of what's the condition, typical condition of a bearing. We always have to have a benchmark, a reference. Based on that, we'll continue monitoring the ultrasound levels, and we have developed a value where we see that going above that value needs to be lubrication. So we will check the lubrication. Basically, it's a marketing trademark, basically. It's just a DV reading that we get from our ultrasound readings.
What's the X? Which one? YX and which one is it?
In this case, what we have here is a DV reading that we get out of our instrument, ultrasound. And in this horizontal, we have time. It's a trend graph of the ultrasound level of each bearing. The key point here is, what is my benchmark? Which one is going to be my re-lubrication point? And which one will be my trigger for doing a vibration analysis for verification of that we have a bearing problem? And what we do here is, from here, we decided that once we get to this point, are we going to continue doing the monitoring with the vibration system or with the ultrasound? Yes, sir.
The dip in the graph is a lubrication event. Is that?
That's a re-lubrication event. Yes, sir.
How do you determine your frequencies?
How do you determine your frequency between your ultrasound reads? Is that monthly? Is that what determines when and how frequently you do that?
Good. In this case, we're doing monthly readings. Every month, because remember, we are coming from systems that they are doing monthly vibration data collection. Okay? And in this case, that vibration, it takes more time. It's not, I need a more knowledgeable person to see that vibration, that ultrasound, which is something additional that we're looking here. We're looking for using a common person, knowing data collection, and ultrasound is much easier to analysis than vibration. So we're doing monthly readings so we can avoid the vibration analysis. Here.
To what level of breakdown issue do you guys actually do a root cause analysis? Does it have to be a major event, or do you do things for something as simple as a proc switch fails?
Can you give me more about your question? I don't.
When you decide to do a root cause analysis on a piece of equipment, okay, does it need to be a major event, hydraulic pump fails, that type of thing, or do we get right down to where we start to look at small events, such as something as simple as a proc switch that fails?
Okay, the question is, to be clear that I understand, is when do we do the root cause analysis? Typical, you will start doing root cause analysis based on dollars. Basically, you will start making a formula which is different factors. I have customers that they say, for me it's more important safety. Environment for others. And for others I say just product. Based on those factors, we will develop a formula that would say, if this failure is caused on this asset, which already has a criticality analysis on it. Everything starts here. Excellent. If you don't have a criticality analysis on your plant assets, doesn't work. You need to do a criticality analysis. And I'm talking about not A, B, and C. I want to divide, I want to be able to define this pump is more critical at this point because this one is 812 and this one is 1020. This one has a higher. Then after that, we will bring another part of the formula that will say, well, environment, do we have any complaints? Product loss should be the second one, and based on that we'll set up it's like a matrix. But you will see that first we will start making root cause analysis of failures that cost more than 10,000, to give you a number. But once we see the results of those, management will say, can you lower that to 5? And can you lower that to less number? And today I have one plant where every failure is being analyzed and is being reported. Because what we have seen in the past is, amazingly, I don't know why, but when we start doing failure modes, failure analysis, root cause analysis, failures rate lower. Magically. Every time that I go to a plant and I say, from now on, every failure needs to be analyzed and reported, failures drop. The failures number drops because people are more concerned. And I'm always saying, we're not looking for people. We're looking for reasons. Because nobody wakes up in the morning and I'm going to wipe up everything today. No. It's just the system is not working properly. So that's really important with the root cause analysis process. But I have plants that say, and it's a cement plant, every failure needs to be reported. And I have another one that say every failure needs to be reported within 48 hours. Because that's the next step. Once you start doing failure modes, root cause analysis, they put time on it. Because there is a lot of money there. Next.
You talked about operations excellence as being the next step. So extent do you see operations getting involved into the reliability program?
Oof. I would say operation has a 50% of the success. 50%. If we don't get involved, operation never works. Never. Because look at it in a simple way. I'll explain it the complicated way. The simple way is you're fixing something and he's just doing what? Breaking it. I have a customer now that they want operation to do the data collection. Excellent idea. Not doable. No way. I have tried like 4 times. Why it failed? Because they do not sell that to operation. Right now, the biggest initiative that I have in the Caribbean is TPM. Everybody's looking for TPMs. And I love it. Because we are showing the operation people how to take care of their assets. And within that part, it will go maintenance. So part of, I don't have the slide here, part of initiative when we're talking about reliability is culture. If you don't work, I have this other plant, well, this is a corporation. Puerto Rico, they have 5 pharmaceutical plants. You know what they did? 2009, they invest $180,000 just on training. They didn't buy an instrument. The worst year within the pharmaceutical industry, they did $180,000 just on training. Because culture is more important. We can sell you a lot of instruments, toys. But if you don't have a person behind that instrument that has a philosophy, as we were talking this morning. You saw Paul Campbell's presentation? I've been talking to Paul for years, trying to learn. One of his best secrets is people. For the next year, we're going to be doing a lot of training. And you have to work with that part. And when I'm doing public courses and somebody calls, who should be in your training? Vibration. I'm an instructor for Mobius. They call me and they say, Felix, who should be in your training? You're doing vibration level 2, whatever. Who should be there? And I say, everybody. They say, why? Yes, because the person that you want to get certified, yes, he will go there and do a certified. But you should also send the operation people. So they will start learning awareness. What did they do in vibration? What did they do with the ultrasound? And there is when you start making a change. You that work on the ultrasound, when you go to somebody on operation and say, well, that bearing is bad, what did they say? Not to me. It's working perfect. But if you take the time, let me show you. You see this DB? When he gets here, we're doing money. When he gets here, he was already here. We did the relubrication, came down. But now it's going up again. It means that there is a problem. And it's not because Felix said so. No, I have an instrument. Show to them. You will see change. But if you don't get operation on this room, on this type of conference, you're not going to make a change. Believe me. Next. Well, thank you.
Thank you.